Welcome travelers and design lovers to a journey into architecture built for chaos, where hotels face storms, heat, floods, and ice with remarkable ingenuity. We explore resilient materials, smart engineering, and daring locations that keep guests safe and comfortable when nature turns extreme. From hurricane-proof towers to desert retreats and polar lodges, these structures redefine survival and luxury. Expect insights, visuals, and facts that inspire confidence during the planet's toughest moments. If you enjoy stories like these, please subscribe. Number 5. Stormproof shells. Stormproof shells refer to the external structural systems hotels use to withstand extreme wind, debris impact, and pressure changes caused by hurricanes, cyclones, and severe storms. These shells rely on reinforced concrete, steel framing, shear and aerodynamic shapes that reduce wind resistance and uplift forces. Impact-resistant glass, tested to survive high-velocity debris, prevents internal pressurization that often leads to roof failure. Sealed building envelopes block wind-driven rain, while storm-rated doors and shutters protect vulnerable openings. Roof systems are mechanically fastened and often sloped or curved to minimize wind lift. Materials are selected not only for strength, but also for durability in salt, humidity, and repeated exposure to harsh weather. Structural connections between walls, roofs, and foundations are continuous, creating a single unified load path that transfers storm forces safely into the ground. Advanced engineering models simulate worst-case storm scenarios to guide design decisions. Together, these measures allow hotels to remain structurally intact during violent storms, protecting occupants and reducing long-term repair needs while ensuring rapid reopening after extreme weather events occur. Number 4. Flood-ready builds. Flood-ready builds focus on minimizing damage from rising water, storm surge, and heavy rainfall by adapting hotel structures to coexist with flooding rather than resist it completely. Elevated foundations lift critical spaces above expected flood levels using stilts, piers, or podiums that allow water to pass underneath without harming the main structure. Ground floors are often designed as sacrificial zones with water-resistant materials that can be cleaned and restored quickly. Electrical systems, generators, and mechanical equipment are placed on upper levels to remain operational during floods. Drainage channels, permeable surfaces, and retention basins manage water flow and reduce pressure on surrounding infrastructure. Some hotels incorporate amphibious foundations that allow parts of the building to rise temporarily with floodwaters, guided by vertical supports. Waterproof membranes and sealed joints prevent prolonged moisture intrusion that can weaken materials. By anticipating flood behavior and designing accordingly, these hotels limit downtime, reduce structural deterioration, and maintain safety for guests and staff when water levels rise unexpectedly or repeatedly. Number 3. Heat-defying design. Heat-defying design addresses extreme temperatures by reducing heat absorption, improving thermal regulation, and maintaining comfort during prolonged heat waves. Hotels use reflective roofing materials and light-colored facades to deflect solar radiation rather than absorb it. Thick walls and high thermal mass materials slow heat transfer, keeping indoor temperatures stable throughout the day. Strategic building orientation limits direct sun exposure on critical surfaces, while deep overhangs, louvers, and shading screens block intense sunlight. Natural ventilation systems encourage airflow by harnessing prevailing winds and stack effects, reducing reliance on mechanical cooling. High-performance insulation and airtight construction prevent external heat from penetrating interior spaces. Landscape surroundings, including trees and green roofs, lower ambient temperatures through evapotranspiration. Energy-efficient cooling systems are designed to operate reliably under extreme demand without failure. These combined strategies reduce internal heat stress, protect building materials from thermal degradation, and ensure that hotels remain functional and comfortable even during record-breaking temperature extremes over extended periods of time. Number 2. Earthquake Smart. Earthquake Smart design enables hotels to absorb seismic energy while minimizing structural damage and risk to occupants. Flexible structural systems, such as steel frames and reinforced concrete with ductile detailing, allow buildings to bend without breaking during ground movement. Base isolation technology separates the structure from the ground, using bearings or sliders that reduce the transfer of seismic forces. Shock absorbers and dampers dissipate energy by converting motion into heat, limiting sway and vibration. Uniform mass distribution and symmetrical layouts prevent uneven stress concentrations that can lead to collapse. Foundations are engineered based on detailed soil analysis to avoid amplification of seismic waves. Non-structural elements like ceilings, partitions, and fixtures are securely anchored to prevent injuries. Redundant load paths ensure that if one structural component fails, others continue to carry the load. These measures allow hotels to withstand earthquakes with minimal damage, enabling faster recovery and continued operation in seismically active regions worldwide. Number 1. Self-sustaining power. Self-sustaining power systems allow hotels to remain operational when external utilities fail during extreme weather events. On-site renewable energy sources, such as solar panels and wind turbines, generate electricity independently from the grid. Energy storage systems, including advanced batteries, store excess power for use during outages or peak demand. Backup generators provide additional redundancy, ensuring uninterrupted operation of critical systems like lighting, communications, and climate control. Smart energy management systems balance loads, prioritize essential functions, and optimize efficiency in real time. Water heating, lighting, and ventilation systems are designed to consume minimal energy without sacrificing performance. Fuel supplies and maintenance protocols are planned to support extended autonomous operation. By reducing dependence on external infrastructure, these hotels enhance resilience during disasters, protect guest safety, and maintain essential services even when surrounding areas experience prolonged power disruptions or infrastructure damage. Thanks for watching and spending time exploring resilient hotels with us today. We hope these designs spark curiosity and respect for human ingenuity against nature. Stay curious, stay safe, and keep discovering remarkable places around the world with us. Your support helps channel grow and bring more stories. Please subscribe.